All right, hello everybody. We're going to look at 45, 45, 90 triangles here. So to begin the lesson, if you look right here, we have this thing called a friendship star. And so the first question asks you to figure out which ones are congruent. So if you look, obviously the block in each corner, those blocks are congruent because they're completely empty. But the main thing I would hope you noticed is that the block right here, the block right here, and right here. So the blocks that contain a triangle are all congruent because they're all congruent triangles in there. And then from there, classify the triangles by their angle measures. So if you look, because each triangle contains the corner of a square, those must be 90-degree angles that would make them right triangles. Okay, and then now classify them by their side lengths. So if you look, let me focus on the one on top. Notice on the left, it's an entire side of the square. And then on bottom, it's an entire side of the square. Notice that happens for every single one of these dark triangles, the shaded in triangles. So what do you call it when two sides are congruent? We did that lesson a while ago. That's isosceles triangles. And then lastly, what are the measures of the acute angles? So if you look right here, you're taking this diagonal and slicing it right down the middle. So you're slicing right through the middle. So if you had the square, this was supposed to be 90 degrees, but it's been cut in half. What's half of 90? That'd be 45. And over here, what's half of 90? Well, that would be 45. So I hope when you get here, you notice that the triangles have a 45-degree angle, a 45-degree angle, and then a 90-degree angle. So with all that, you arrive at this right here, this table. So what I want you to do, this will take a while. In class, we're going to take, as a group, a couple minutes and work on this together. If you're at home, take the time to go through this. It's important practice on Pythagorean theorem, and it will help you to understand the whole thing. I'm just telling you, if you skip this for the sake of speed or whatever, to get this over with, you'll miss a big part of learning what's going on. So take the time to go ahead and fill out this table. I'm not going to do the whole table, but I will go over some of what's happening here. So let's do the first line. So if it's a 9 by 9, let's do a better pen here. So if it's 9 by 9, okay, so if we're 9 by 9, and then the length of each leg, and then the length of the hypotenuse, and then the ratio of hypotenuse to leg. Of hypotenuse to leg. Okay, so let me make this big, and I'll work through what we're trying to do here. Okay, so if we go 9 by 9, what is the length of each leg? So, let me go back to this. If we're looking at what we have here, we have, if this whole block is 9 inches by 9 inches, then each individual is going to be 3 by 3. So like if we focus at this will be 3 inches, 3 inches, 3 inches, 3 inches. So every side is 3 inches. So when we're going back to this table, if it's 9 by 9, then the leg would be 3 inches. Okay? So if the legs, you can hardly see that right there, but I wrote a 3 right here. So it's 3 inches. And then what would the hypotenuse be? Well, if the leg is 3, and since they have two identical sides, the other leg would be 3, you'd have to use Pythagorean's theorem. So what you're going to do is you're going to do 3 squared plus 3 squared equals the missing side. We'll just call it h for hypotenuse. So it'll be 3 squared plus 3 squared equals h squared. Okay, so you add those together. 3 squared is 9, plus 9 will get 18. My pens are on their last leg here. We get 18 equals h squared. Okay, and then we do square root both sides. So we now have h equals the square root of 18. Now, when you take the square root of 18, you have to simplify it. So I'll do it over here to the side. Square root of 18, you break that up. That's the same as having the square root of 9 and the square root of 2, right? Because 9 times 2 didn't make 18. Now, I could have done 3 times 6. The reason I didn't pick 3 times 6 is because neither one of those do anything when you take the square root. But if I do the square root of 9, that would equal 3. So my answer is 3 square root of 2. All right? So the hypotenuse right here is 3 square root of 2. All right? So hypotenuse, 3 square root of 2. So what is the ratio of the hypotenuse to the leg? Well, the ratio, this is going to be 3 times root 2, and this is 3. So what is the ratio? So if I was to write them, let me do it over here. It's like hypotenuse is 3 root 2 compared to the leg, which is 3. Well, what I'm doing right there, I could take both of these and divide by 3 and be left with root 2 to 1. Right? So if you divide this by 3, it's just root 2. Compared to if you divide this by 3, it would just be 1. So the ratio of hypotenuse to leg is root 2 to 1. That's the ratio. Okay? Let me do one more example. Let me pick a harder one. So if we're doing this table, because again, I'm not going to do this whole table. I want you to take the time to do it. Let's do this one where the length of hypotenuse is 6 root 2. So, so this time the hypotenuse is 6 root 2. Okay, so let me make this big. You can see how I do this. Now this is great. This helps you to understand what's going on here, but it's also just great practice for doing Pythagorean's theorem. Okay, so the hypotenuse is 6 root 2. So if that's 6 root 2, now remember, both of these are the same, right? We're imagining we're doing one of those, the image on that friendship square where the triangles have 2 legs that are the same. So I could just call this like x, and I can call this x. Okay, so if I do that, it's going to be x squared plus x squared equals 6 root 2 squared. The whole thing is squared. Okay, can you see that okay? Yeah, because remember, a squared plus b squared equals c squared. So if we x squared and x squared, there's 2 of them, so you can just make that 2x squared. And then with this, square both of these. So 6 squared is 36. Root 2 squared is just 2. So we get 2x squared equals 72. Okay, divide both sides by 2. So we now have x squared equals 36. Now take the square root of both sides. This one's nice and simple because the square root of 36 is 6. So x equals 6. X equals 6. So both legs are 6. If you go back and look at what we're doing on the table, when it wants us to find the dimensions of the block, so like when you're doing something like this, remember, if one leg is 6, that means the side of the square is 6 because there's 3 squares. Just multiply that by 3. So the Block must be 18 by 18. And then the last thing is the dimensions, the ratio comparing hypotenuse to the leg. And once again, the hypotenuse is just root 2. So the hypotenuse, because it's 6 and then 6 root 2. So what do you multiply the leg by to turn it into the hypotenuse? You multiply it by root 2. The most important thing is to understand this ratio, that whatever the leg is, you multiply it by 1 to find the other leg, meaning they're both the same. Whatever the hypotenuse is, you'd multiply it by root 2, okay? So this is how we end up doing this table. You have a bunch of lines to do. Go through them all. It'll give you the practice and let you start seeing how this thing works. So go ahead and do that, and then you'll be about halfway through this lesson.